progress part, finite element of analysis of spring back of sheet metal using ANSYS workbench. Then this is the index. So I'm going to tell you about how to get spring back using FEA in ANSYS. So this is geometry. First is punch, second is sheet metal, and third one is the die. Third one is die, which I'm going to use. Then the material properties which I'm going to use for punch and die is structural steel, and for sheet metal I'm going to use non-linear properties of aluminum alloy 2023T3. I have given a multilinear isotropic hardening so as to give a non-linear properties to the material, and Young's modulus, bulk modulus, and shear modulus is as shown in the figure. So what is spring back effect? So in case of sheet metal bending process, when we apply a bending pressure so as to deform sheet metal, so there will be a deformation of that sheet metal, but once we remove that bending pressure, it will regain to its not directly to its original shape, but it will regain its elastic energy, thus causing a spring back effect. So it is a material defect, but it is very important phenomenon. As you can see, this is a spring back effect. When we remove a pressure, it will come back to a little bit of gaining its elastic energy. So we can see this using a stress strain diagram also. It is directly proportional to a tensile strength of the material. The higher the tensile strength, higher will be a spring back effect. And it is also dependent on the bending angle of and a sheet metal thickness. So this is elastic energy recovery. So this is the spring back effect. Yeah, so this is modeling of spring back effect in case of sheet metal bending. So what I'm going to do, I'm going to give a frictional contact between the surfaces here. You can see that in the model as well. So I've used a frictional contact, and here to this with the friction coefficient as 0.2, and I've used a augmented Lagrange method, and I've used damped effects so as to give a perfect treatment of geometry. Then the second contact is frictional contact between the sheet metal to punch. So again I have given friction coefficient as 0.2, as you can see in the model. Yes, so I have written this in the PPT as well. So next is joints, which are I have given a rigid to punch and die. That's why I have given joints. So here you can see I have given as this material are rigid and the stiffness behavior is rigid. So as to move them and give proper contacts and boundary conditions, I have given joints. So I said that I want to fix this to ground, and the second joint I have used is moving this punch with respect to die. So I have given X displacement to the model in this way. Then the last is next I have given a joint displacement to the model. So as you can see that I have given a joint displacement in X direction with 4 steps as 5 mm, then 10 mm, 13 mm, and then again to 10 mm, just to get a spring back effect. And this is the mesh which I have used. As we have a rigid bodies, we will not be getting mesh over here, but otherwise we'll have a smooth meshing in this area. I have used face meshing as well, so as to have a mapped meshing. And the analysis settings I have used is program control, and with the 4 load steps. Program control and the 4 load steps. Alright, and then so as we can see a plastic strain in the model as this. Okay, now you can see a plastic strain in the model. So this is at third step. As you can see, I can show you my results. So these are my plastic strain. So my sheet metal is deformed. You can see that in the video as well. So this goes to a little bit of original shape, regaining its elastic energy, hence getting a spring back effect. Plastic strain at the end time step is again the same. Total deformation at third step is 28 mm, and at the end step it is 26 mm. So there is a 2 mm elastic gaining back property. Total strain at third step is again 0.032 as in 3%, and at the end step it is 3.1%. And equivalent stress at third step at the maximum deformation, which we have given, it is 10 mm. The equivalent stress regarding to that, it is 341 MPa, and at the last step it is 316 MPa. Hence stress is also reduced during spring back effect. Yes, that's it. So I have given this in the results, and spring back it is total strain minus plastic strain. And next step, in my last report, I'm also going to give analytical calculations of spring back effect and then compare it with the FEA results. Okay, thank you.